In this video, we're going to be expanding on our knowledge of predicting precipitate formation in double displacement reactions and looking at how they relate to dissociation reactions of ionic compounds. If we take a look at this double displacement reaction here, we can take the cations silver and ammonium and flip them in order to predict what our products are going to be, that being ammonium nitrate and silver bromide. Now that we have our products, we need to use our solubility table in order to predict which one will dissociate and which one will form the precipitate. We can see that pretty much all nitrate compounds are fully soluble in water, but if we look at bromide here, we see that silver falls on the poorly soluble category, meaning that ammonium nitrate is going to dissolve, so we can write aqueous here, and silver bromide is going to be our precipitate. If the reaction is written in its double displacement form, we call this the formula equation because the chemical formulas of all compounds are listed out fully. However, this reaction doesn't exactly show what's happening because we know that ammonium nitrate is going to dissolve, and since this is an ionic compound, we would expect that this compound would dissociate. And if it dissociates, the ions would not stay together, but they're written together in the formula equation, which shows that this equation is not completely correct. So in order for this equation to be correct in terms of showing which ionic compounds have dissociated and which ionic compounds haven't, we need to take all of the compounds that will dissociate in solution and break them into separate ions. Therefore, if we look at our reactants, we see that both silver nitrate and ammonium bromide exist in solution form because the question explicitly says so, but we can check the solubility rules to show that both of these compounds dissolve fully in water. Now, in order to show this dissociation, we need to break them into separate ions, meaning that silver nitrate will be written as Ag plus and NO3 minus, showing that the ions have been separated, and likewise ammonium bromide will be written as ammonium and bromide ions separately, again showing that the compounds have dissociated in water. Now, this doesn't apply to every single compound. We know that silver bromide dissolves relatively poorly in water. Therefore, the only compounds that are not written as separate ions like this are in the case of precipitates, because again, they do not dissociate completely. So ammonium nitrate in the products is written as separate ions in order to show that it has dissociated like this, but silver bromide, because it exists as a precipitate, we would write it as normal to show that this compound dissolves very poorly. This equation, or this form of the equation rather, is what we call the complete ionic equation because it shows which compounds dissociate into separate ions and which compounds remain in their ionic compound form. Now, as we've looked at with previous reactions and as we know with mathematical equations, whatever appears in the reactants and the products means that there has been no change in the overall structure, which means that we can cancel them. So we see that nitrate appears in the reactants and the products unchanged, so we can go ahead and cancel that, and likewise for ammonium. And if we rewrite the equation without the ions that appear on both sides of the reaction, we can write out the reaction like this, with Ag and Br coming together into an AgBr precipitate. Now, if we take this equation and flip it, so if we have it going the other way, this is what we call a dissociation reaction, which we've already seen. So we can see that simply by taking a formula equation, breaking it down into the complete ionic equation by identifying which ionic compounds will dissociate completely and removing ions that appear on both sides, we can discover a simple dissociation reaction that we see here. And because we've eliminated the ions that appear on both sides of the complete ionic equation, this is what we call the net ionic equation, because it only shows the ions which come together or separate from each other with respect to the precipitate compound that doesn't dissolve completely. For practice, to make sure that you understand how to write the formula, complete ionic and net ionic equations, take a look at the solubility table here and see if you can write out each of the three equations for these situations here.